Just going to do a quick video tonight. I did get the camshaft for the 406 project. Did end up going with the Howards. It's 237, 245 duration at 50. And then with the 1.6 rocker, it's going to be 600, 600 lift, 110 lobe separation plus 4, so 106 center line. On the intake, like I said, this camshaft fits this build perfect. I might end up going with a 165 rocker to get it around 615 lift, but we'll see. Just kind of test fitting. I got the timing chain on. I'm at a good stopping point to basically my next step. I'm going to check rod clearance to the cam lobes and then check piston to valve clearance. And then I should say I'll degree the cam, then check piston to valve clearance. But basically just going through kind of the first step, got the cam out of the box, cleaned it up. I just used this Lucas assembly lube on all the lobes and all the journals. So cleaned it up, put it in there, and then I will check piston to valve and get this thing degreed. And we'll go from there on that. But I'm excited. I did get the cam. Next step is going to be lifters, and then push rod length and so on and so forth. But wish I would have done a little bit of a video on the camshaft itself. If you look closely, you can kind of see the lobes down in there. But the core of the camshaft I was really impressed with on this Howard's cam. Looks great. Definitely looks to be a better quality core than what I've seen in the past from some manufacturers. So I was a little worried. I used this same cam in another engine, but it was the factory. So it's a small block Chevy, but a 96, so it's a factory roller motor. And it was the better core as well. So I just wasn't sure with this application if it would be the same core. And I know it's a little bit different core, but it's the same materials what I'm getting at, and it was. So that's awesome. I've had a few others, not from Howard's, that I just wasn't impressed with what the core looked like. So this one looks like a really nice piece. I'm happy about that. But one thing I wanted to talk about real quick is I mentioned I was going to be checking piston to valve clearance, and I don't have my lifters yet. The other thing is this is a hydraulic, so checking piston to valve clearance, you can't really do it accurately with a hydraulic lifter when it collapses. So if you watch it closely enough and you're positive it's not collapsing, you could, but the best way to go about it is to take a hydraulic roller lifter or a regular hydraulic lifter and take it apart and make it a solid. So this is actually just an old LS1 lifter, and it's actually the same, I think it's 842 thousandths on these, which is the same as this for the bore diameter. So what I did is I took this hydraulic roller lifter apart, took the plunger out of it, and if you actually take it and flip it upside down internally on this LS1 lifter, it's the exact length, let that focus in if it will, it's the exact length you need to be able to stop this from collapsing and to reinstall that clip. So I don't care if you had an 800-pound spring right now, this thing will not collapse. It's solid internally. Just by taking that clip out, getting that top retainer off, and then there's a plunger inside there, taking that plunger and flipping it 180 degrees and then putting this back together, that makes these LS1 lifters a solid lifter. Now, obviously this is just for checking piston to valve clearance. The overall length of this lifter isn't going to be the same as what I'm going to use, but this will work absolutely perfect for checking piston to valve, because I can put this lifter in this engine, and I'm not going to now because I got to clean it up first. Put my cylinder head on. I've got a couple different push rods, so put the push rods in, put a rocker arm on, and I can roll the engine around. I'm just going to use clay, so with this method, and I'll be able to see the indentations in the clay on the top of the piston once I pull it back apart, and then I'll be able to measure that, and that'll give me an idea where piston to valve clearance is. But if you don't take your hydraulic lifters apart to make sure they're not collapsing, and you do that same method with the clay and you're rolling it over, well, chances are that lifter's collapsing and you're not getting accurate piston to valve clearance readings. So just make sure you have like something like this, a mock-up lifter or piston to valve clearance checker lifter, I guess you'd call it. But just a tip there. And like I said, I found the early LS1 lifters, and they're in a bunch of LS stuff, but the early style, if you take them apart, flip that plunger upside down, it's the perfect lifter, and I got a couple of them just for doing this. So that'll work out great. We'll get piston to valve clearance checked. Honestly, I know off of previous experience, I'm going to have probably right around 120 on the exhaust and 140 on the intake, which is a mile. I mean, that's, guys say 80 thousandths, 100 thousandths is a good rule of thumb. I've ran stuff tighter than that, and that engine had an 8,000 RPM rev limiter, and I was more around 60 on the exhaust and 80 on the intake, and never once had an issue. So you can run the stuff tighter than that. I don't necessarily like to, but for example, the engine I did that on, I didn't have much of a choice what I was doing. So good rule of thumb, 80 on the intake, 100 on the exhaust. But yeah, we'll get this thing chugging along here and continue this build. So I'm excited. One more piece showed up tonight. I think that'll do it. Thanks.